Alright guys, here we go. So you already have a video up for a mass to you have a mass to volume and a volume to volume uh, video already posted on Google Classroom. I need you guys to watch that video because some of all these concepts will be on the test. Remember, mass to volume is grams to liters. Volume to volume is liters to liters. In a volume to volume stoichiometric problem, it's literally just one step, molar ratio. It's not, I'm so used to saying molar ratio, it's actually just ratio between the two compounds that you're comparing it to, because you'll see liters and liters. You won't see mole over mole, you'll see liter, liter. And watch that video for a recap of that. Today we're going to be discussing a mass-to-mass problem, and we're going to be going back over limiting reactants and percent yields. And then after this video, you should know all the concepts and should be prepared for your chapter 11 test. So let's jump right in, all right? Here we go. So this is a test question, all right? So this equation that you're about to see, it is a test question. And here it is. In a thermite reaction, powdered aluminum reacts with iron 3 oxide to produce aluminum oxide and molten iron. What mass of aluminum oxide is produced when 2.3 grams of aluminum reacts with iron 3 oxide? So here's your balanced chemical reaction here. And here we are. Let's examine your question. So remember, we're going from, it says what mass, so the question is what mass of aluminum oxide, that's this. So mass, what unit is for mass? Grams. Is produced, so we're looking at a product here. This is on the product side, reactant product. Is produced when 2.3 grams of aluminum reacts with iron 3 oxide. So you take what's given to you here. We start with the mass of aluminum. 2.3 grams of aluminum. All right, so here we go. Let's bring it out over because this is a big equation. 2.3 grams of aluminum. What's always your first step, please? Bry? Yes. Convert to moles. You have grams of aluminum on the bottom, moles of aluminum on top. Grams are on the bottom, Briar, because we're getting rid of grams. We don't want it. We want to get to moles. So that's why grams on the bottom, moles on top. Anytime you have one, when you see a mole, you always put one next to the mole when you have a grams per mole ratio. Now, for grams, you got to decide what goes next to the grams for aluminum. Well, you got to check out what the formula mass is. What's the molar mass of aluminum? Look at the periodic table and you see that aluminum is 27 atomic mass units. That's the weight, the mass of aluminum is 27 atomic mass units. Convert that to molar mass, which is grams per mole, it becomes 27 grams per mole. So 27 grams per 1 mole. That's the molar mass of aluminum. I give you all the weights on your test. I tell you what everything is. You have a key that you can look to know all the weights, so you don't have to guess that or memorize that. That's your first step, convert to moles. What's your second step? Yes, molar ratio. You're starting with this, 2.3 grams, and you're trying to figure out how many grams of aluminum oxide is produced. So if you start out with grams and you're trying to figure out the grams of this, that's a mass of this, and you want to know the mass of that, what kind of problem is that? Right, a mass to mass problem. That's a mass to mass stoichiometric problem. So first step, convert to moles. Second step, molar ratio. You have your moles of aluminum. And you're trying to get to here because the whole goal is what mass of aluminum oxide is produced from 2.3 grams of aluminum. So you put that on top, moles of aluminum oxide. Now, the molar ratio. You look at the coefficients in your chemical equation. What number is in front of this? Just a 1. It's blank, so it's a 1. What number is in front of aluminum? 2. So 2 goes next to aluminum. 1 goes there. The molar ratio is a 1 to 2 ratio. That's your second step complete. 2 moles per 1 aluminum oxide. That is your molar ratio. Your third and final step is convert to the desired unit. The desired unit, since it's a mass-to-mass problem, is the grams. If this was a mass to volume problem, the desired unit would be liters. We'd be converting grams to liters. in which we would use the 22.4 liters per mole, which is always the same at standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere of pressure. That's another video. Recap that, please. But that is always your final step in a mass to volume is 22.4 per 1 mole. Here, though, it's grams. So we got to go from, so we're getting rid of all this stuff. Now we need to go to moles of aluminum oxide. So grams of aluminum oxide, because that's the goal. So we put moles on the bottom because we don't want moles. We want grams. Grams goes on top. It's the liter. That's what we want. Here we go. One always goes next to the mole. Remember that. Grams per mole, that's a molar mass problem. Molar mass. So you got to figure out the molar mass of 2 aluminums, each weighing 27, and 3 oxygen, each weighing 16. 6, 12, 30, 40, 50, 60. Should be 100 grams per mole. You can check my math because I just did it real quick. Should be 100 grams per mole. 2 aluminums, each at 27 grams, and 3 oxygen, each at 16, should add up to 100 grams per mole, hopefully. And then what do? You multiply the top, and you divide it by the bottom. I'll bust out my calculator for this one. So you take your, here we go. Take your 2.3 times by 100. Obviously that's, here we go. So you'll have 232, and then you divide that by the bottom. Oh, try to figure out how to use this. Oops, sorry, give me a sec. How do I keep going? 27 times 2. Calculator is broken. For some reason, it's not letting me. Obviously, 27, there we go, 54, 232 divided by 5. Let's see if it lets me at least do that. Yes. Equals 3.9 grams. 3.9 grams of aluminum oxide are produced from 2.3 grams of aluminum. So 2.3 grams of aluminum produces 3.9 grams of aluminum oxide. Please pause, rewind, replay this video because this is a test question and you need to know it. So please study this. I'm going to go on to a limiting reactant problem now. Alright guys, this is a limiting reactant problem. This is actually taken straight from your test, so pay attention. Please, I'm hoping you're watching these videos because because you need it. So here we go. Remember, limiting reactant, there's always a limiting reactant and an excess reactant in a chemical reaction. Well, most of the times anyway. Sometimes they run out at the same time. You never know. But usually there's something in excess. When I say limiting reactant, I mean what I'm referring to is when a chemical reaction occurs, something is going to run out before something else does. The one that runs out first stops the reaction. Once it's all depleted, once it's all gone, the reaction stops, and then whatever's left over is your excess reactant. That limiting reactant determines how much of the product is produced. Like for instance, in this equation, the equation is determine the limiting reactant using a reaction in which 3.5 grams of copper, so a piece of copper is added to a solution, containing 6 grams of silver nitrate. So you have this solution in a vial in a lab. You take a piece of copper, you stick it in, a chemical reaction occurs. Chemical reaction in which copper nitrate and silver are produced. Okay. So one of these, the copper or the aluminum, silver nitrate will run out first, and then there will be one left behind in excess. Okay. So here we go. Sorry. The way you do and set up a limiting reactant problem is you always first take the information that's given to you, and then you do two mass to mass problems. Remember, grams convert to moles, molar ratio, get to the desired unit, which is grams. You do two of those, and you do it with the same. You do it with this. The molar ratio step is always with the same product. You pick a product and you stick with it, and you find out which number is smaller. The number that's smaller at the end is your limiting reactant. Not the answer, not, I'll explain once we get to it. Let me solve the problem, all right? So here we go. You have 3.5 grams of copper. All right, let's do a mass-to-mass problem. And so you need to determine which runs out first. We are going to take your 3.5 grams of copper in your chemical reaction. We're going to pick one of these two to compare it to. Remember, molar ratios, you pick two to compare it to. So pick one. Obviously, silver is going to be your best bet because silver is just one element compared to that copper nitrate, which has copper, nitrogen, and oxygen in it. So that's you might not want to do that. Now let me pull something up real quick. Give me a second. 108. All right. Minimize this. Okay. Remember, I tell you all these. Silver weighs 108 grams, or atomic mass units, but it gets converted grams per mole. All right, so here we go. You have 3.5 grams of copper. What's your first step in a mass-to-mass problem? Yes, convert to moles. You have copper on the bottom. You have grams on the bottom because you don't want grams, you want moles. We know that copper weighs, should have looked at too. Give me 1 sec, I'm sorry. Copper, I forget what it weighs right now. Copper weighs 63.5 grams. There we go. All right, let me put this. All right, here we go. So you look up at a periodic table. Remember, one always goes next to the mole. You look up at the periodic table and you figure out the atomic units of copper. Then you just convert it to grams per mole, which is 63.5 grams per mole. That's your first step. Second step is mole to mole ratio. You have moles of copper on the bottom because you don't want moles of copper. You are looking for moles of silver because that's the one you chose for both problems. It has to be the same to compare it to. So you have moles of silver on top. The ratio is, look at the coefficients or the number in front of it. You have a 1 in front of the copper and you have a 2 in front of the silver. Boom, a 1 to 2 ratio. 2 silvers, 1 copper. That's your second step. Your third step is convert to the desired unit, which is grams. So we're putting moles of silver on the bottom because we don't want moles. We want grams of silver. The goal is to get to grams of silver. You have 108 per 1. And then here at the very end, we're going to multiply the top divided by the bottom, all right? But I want to save that for last because I'm going to kick the point in at the end. So that's your first mass-to-mass problem. I didn't solve it yet, so we don't have the answer to that mass-to-mass problem, but you're going to end with grams, a specific number of grams of silver produced from 3.5 grams of copper, all right? Well, in this problem, we also know that the solution vial that the copper went into was 6 grams of silver nitrate. So here's our second mass-to-mass problem. Start out with 6 grams of silver nitrate, which is AgNO3. All right? AgNO3. First step in a mass-to-mass problem, yes, convert to moles. You have grams of AgNO3 on the bottom, moles of AgNO3 up top. Moles always goes next to the one goes next to the mole. This is a grams of silver nitrate. You have 1 silver weighing 108 grams. You have 1 nitrogen weighing 14 grams. You have 3 oxygen, 3 of those, each weighing 16 grams. So you have 12. 170, I hope that's a 0. 170 grams of silver nitrate. That's what all the elements in that specific compound weigh. 170 grams. That's your first step. Your second step is, yes, molar ratio. You take your moles of silver nitrate, AgNO3, and you're comparing it to the same thing, to silver. If you switch it, then you mess up your problem.